Bismillah ar-Rahman ar-Rahim. Our subject is General Science and its code is EDU 102 and lecture number 19. The topic of today is atomic theories. The outlines of the lectures are, first of all, the introduction about the main topic, and then Democritus atomic theory, then Dalton's atomic theory, then Thomson's discovery of electrons and Rutherford's nuclear atom, Bohr electron orbit. Timeline of atomic theories. Definitely with the passage of time, the different theories came by the different philosophers, physicists or chemists or whatever you can say, the scientists were there. So they discovered different theories. The first theory, that was Democritus' discovery of atoms, that was in 460 BC, and then Dalton atomic theory, and that was in 1803. Then Thomson's discovery of electrons, that was in 1897. Then Rutherford's nuclear atom, that was in 1911. And then Bohr electrons orbit, that was in 1913. So when we discuss about the atomic theories, then all matter is made up of atoms, we all know. So this is something we know, take as a given, and one of the things you learned right back at the beginning of high school or secondary schools, chemistry classes. Despite this, so our ideas about what is atom are surprisingly recent, as little as 100 years ago. Scientists were still debating what exactly an atom looked like. This graphic takes a look at the key models proposed for the atom and how they changed over time. Though our graphic starts in the 1800s, the ideas of atom was around long before. In fact, we have to go all the way back to ancient Greek to find its genesis. The word atom actually comes from ancient Greek and roughly translates as indivisible. The ancient Greek theory has been credited to several different scholars, but is most often attributed to Democritus, and as we know that his life is from 460 to 370 BC, and his mentor Leucippus. So though their ideas about atoms were rudimentary compared to our concepts today, they outlined the idea that everything is made of atoms, invisible and indivisible spheres of matters of infinite type and numbers. And if we see the ancient Greek beliefs, then Leucippus and Democritus were the first to propose in the 5th century BC that all matter is made up of tiny units called atoms. The two philosophers held that these were solid particles without internal structures and came in a variety of shapes and sizes. Intangible qualities such as taste and color, according to this theory, were made up of atoms. However, Aristotle strongly opposed this idea, and the scientific community failed to pay serious attention to it for centuries. First of all, we discuss about Democritus' atomic theory. In this theory, atoms differ in size, shape, mass, positions and arrangements. Atoms are indestructible. Atoms are solid but invisible. Atoms are homogeneous. All matters consist of invisible particles, atoms. Democritus is the first person ever to propose that matter was made up of atoms and are invisible. He named the smallest particle of matter atomus, means not to be cut. The theory of Democritus held that everything is composed of atoms, which are physically but not geometrically indivisible. That between atoms there lies empty space. That atoms are indestructible and have always been and always will be in motion. That there is an infinite number of atoms and of a kind of atoms. Democritus, known in antiquity as the laughing philosopher because of his emphasis on the value of cheerfulness, was one of the two founders of ancient atomist theory. He elaborated a system originated by his teacher Lysippus into a materialist account of the natural world. The atomist held that there are smallest indivisible bodies from which everything else is composed, and that these move about in an infinite void. Of the ancient materialist account of the natural world, which did not rely on some kind of teleology or purpose to the account for the apparent order and regularity found in the world. Atomist was the most influential. Even its chief critic, Aristotle, praised Democritus for arguing from sound consideration appropriate of natural philosophy. And if we see his work, his life, then according to the ancient reports, Democritus was born about 460 BC. Thus, he was a younger contemporary of Socrates and was a citizen of Abdera. So, some reports mentioned Miletus as well as his associate or teacher Lysippus. Democritus is said to have known Anaxagoras and to have been 40 years younger than the latter. A number of anecdotes concern his life, but their authenticity is uncertain. So, the work of Democritus has survived only in a second-hand report, sometimes unreliable or conflicting. So, much of the best evidence is that reported by Aristotle, who regarded him as an important rival in natural philosophy. So, Aristotle wrote a monograph on the Democritus, of which only a few passages quoted in other sources have survived. Democritus seems to have taken over and systematized the views of Lysippus, of whom little is known, although it is possible to distinguish some contributions as those of Lysippus. The overwhelming majority of the reports refer either to both figures or to Democritus alone. The developed atomist system is often regarded as essentially Democritus. Then comes Dalton's atomic theory. This theory says that a chemical reaction is the rearrangement of atoms. Atoms cannot be created, destroyed, or subdivided. All atoms of a given element are identical. All matter is made up of atoms. When two or more different atoms combine with each other, compounds are formed with a ratio. So, Dalton was the first person to recognize a distinction between the basic particles of an element and compound. In 1808, an English chemist, that was John Dalton, further built on a Greek notion of atoms. He postulated that matter is made up of atoms, which are small indivisible particles. He also proposed that while all atoms of one element are identical, they are totally different from those that make up of other elements. Although the concept of atom dates back to the ideas of Democritus, the English meteorologist and chemist John Dalton formulated the first modern description of it as the fundamental building block of chemical structures. Dalton developed the law of multiple proportions, means first presented in 1803 by studying and expanding upon the works of Antoine Lavoisier and Joseph Proust. Proust had studied tin oxides and found that their masses were either 88.1% tin and 11.9% oxygen, 78.7% tin and 21.3% oxygen. So these were tin second oxides and tin dioxide respectively. Dalton noted from these percentages that 100 gram of tin will combine either with 13.5 gram or 27 gram of oxygens. 13.5 and 27 form a ratio of 1:2. So Dalton found an atomic theory of matter and could elegantly explain this common pattern in chemistry. In the case of Proust tin oxides, one tin atom will combine with either one or two oxygen atoms. Dalton also believed atomic theory could explain why water absorbed different gases in different proportions. For example, he found that water absorbed carbon dioxide far better than it absorbed nitrogen. Dalton hypothesized this was due to the differences in the mass and complexity of the gases' respective particles. Indeed, carbon dioxide molecules are heavier and larger than nitrogen molecules. So Dalton proposed that each chemical element is composed of atoms of the single unique type, and though they cannot be altered or destroyed by the chemical means, they can combine to form more complex structures, means chemical compounds. So since Dalton reached his conclusions by experimentations and examination of the results in an empirical fashion, so this marked the first truly scientist theory of the atom. So like solid sphere or bowling ball model. Dalton atomic theory that also has some faults, like he claimed that atoms which have the same mass number are same. It is wrong. Calcium and argon both have the same mass number but are the different elements. And a chemical reaction is a rearrangement of atoms. Atoms cannot be created, destroyed or subdivided. All atoms of given elements are identical. All matter is made up of atoms. When two or more different atoms combine with each other, compounds are formed with ratio. Means two types of atoms can combine to form more than one type of molecule. Like H2O is equal to water, H2O2 is hydrogen peroxide. So atoms of some elements vary in their masses and densities, like isotopes are there, and an atom can be further subdivided into protons, neutrons and electrons. Now we will discuss about the Thomson's discovery of electrons. This theory basically states that the atom consists of sphere of positive charge with negatively charged electrons embedded in it, and an atom is not indivisible is there or smaller pieces, electrons and protons, and the positive and negative charges is an atom are equal. English physicist Joseph J. Thomson proposed the plum pudding theory of the divisible atom in 1904, and after discovering electrons in 1897, his model postulated that atoms consist of big positively charged spheres stirred with negatively charged electrons, and he called them corpuscles, like fruit in a plum pudding. He further hypothesized that the charge of positive spheres charge is equal to the negative charges of the electrons. Today we call the positive charged particles protons and negative ones electrons. Sir John Thomson's basically his duration of life is from December 1856 to 30 August 1940, and he was a British physicist and Nobel laureate in physics, credited with the discovery of the electrons, and he was the first subatomic particles to be discovered. In 1897, Thomson showed that cathode rays were composed of previously unknown negatively charged particles, now called electrons, and which he calculated must have bodies much smaller than atoms and a very lower charge to mass ratio. Thomson is also credited with finding the first evidence of isotopes of stable, means non-radioactive elements in 1913 as a part of his exploration into the composition of canal rays, which were positive ions. So his experiments to determine the nature of positively charged particles with Francis William Austin were the first use of mass spectrometry and led to the development of mass spectrograph. So Thomson was awarded the 1906 Nobel Prize in Physics for his work on the condition of electricity in gases. So the next we can say that Thomson discovered the electrons and isotopes, and this model shows that electrons are surrounded by the pudding of positively charged to balance out of the negative charge. Thomson's discovery of electrons. Thomson's claim was that the first model shows electrons are surrounded by the pudding of positive charge, and Thomson's model claimed that if protons were fired at the sheet of gold foil, the protons would go through. And its faults were there, that there was a problem of demonstrating that the atom possessed a uniform positive background charge, and some of the protons were deflected back toward the proton source. Then the next theory is Rutherford nuclear atoms. Rutherford proved, showing experimentation, that the atom contains a central nucleus. And this was how the source was given, and the file was split where the beam of alpha particles passed, and detectors are there, and with the help of gold foil, and he did his experiment. The gold foil experiment is also called or attributed with the Rutherford nuclear atom. He was a British physicist. Ernest Rutherford proposed a nuclear model of atom in which a nucleus exists. In 1911, he also discovered activity in this part, namely the movement of protons and electrons within the central part of the atom. He further postulated that the number of protons in an atom equals that of the electrons. He also hypothesized that more neutral particles exist, so these have to be known as neutrons. Rutherford overturned Thomson's model in 1911 with his famous gold foil experiment, in which he demonstrated that the atom has a tiny massive nucleus. 5 years earlier, Rutherford had noticed that alpha particles beamed through the hole onto a photographic plate would make a sharp edge picture, while alpha particles beamed through the sheet of mica only 20 micrometers or about 0.002 centimeters thick, and that would make an impression with the blurry edges. For some particles, the blurring corresponded to the 2-degree reflections. Remembering those results, and Rutherford had his postdoctoral fellows, Hans Jaeger, and an undergraduate student, Ernest Marsden, refined the experiment, and the young physicist beamed alpha particles through gold foil and detected them as flashes of lights or scintillations on a screen. So the gold foil was only 0.00004 centimeter thick. So most of the alpha particles went straight through the foil, but some were deflected by the foil and hit the spot on the screen placed off to the one side. So Jaeger and Boston found that about 1 in 20,000 alpha particles had been deflected 45 degrees or more. So Rutherford asked why so many alpha particles passed through the gold foil while a few were deflected so greatly. So it was almost an incredible, as if you fired a 15-inch shell at a piece of tissue paper and it came back to hit you. So he also said that an atom is mostly empty space and most of the alpha particles traveled right through the foil, and the alpha particles and nucleus is positive charge, means some alpha particles are deflected by small angles, and the positive charge of atoms are all in the nucleus. Few alpha particles were deflected backwards. Rutherford planetary model. In this model, the mass of atom is concentrated at the center and the electrons orbit the nucleus. And he could not explain why negatively charged electrons remain in orbit. So they should instantly fall into the positively charged. Bohr discovered energy levels and defined Rutherford's planetary model, where the electrons occupy particular orbit or shells around the nucleus of an atom. And his theory is that electron orbit the nucleus without losing energy. Electron's energy level determines the closeness of the orbit to the nucleus, and electrons could move only in a fixed orbit of specific energies. Bohr electron orbit states that how electrons move around the nucleus. Electron orbits, you can say negative are the electrons, positive are the protons, and the ball showing with the green color, that is neutron. So Bohr planetary model explains that Bohr model is an atom with a very small positively charged nucleus that contains proton and neutron, surrounded by negatively charged electrons orbiting around the nucleus. And the problem is that in this model there must be an equal number of protons and electrons, so it is a neutral. But the sum of mass of protons and electrons is very far from the actual mass of an atom. And solution is, in 1932, Chadwick found the reasons for the mass differences is that the nuclei of atoms contains a particle neutron with no electric charge. So this was all about this lessons. Hopefully you have understood each and everything. Thank you very much. Allah Hafiz.